Now let's express a vector as a sum of two other vectors with the dot product. This is sometimes we want to express, let's say, this vector A as the sum of a vector B, or a vector in the direction of vector B, and a vector that is orthogonal to vector B. So here we have this vector, let's say vector A, is, we know it's equal to the sum of this vector that is parallel or in the same direction as vector B. So it's the sum of this vector plus this vector. So we have vector A is equal to the projection of A onto B, projection of A onto B, plus the orthogonal of B, orthogonal of B. If we want to know this vector, the orthogonal vector would be this orthogonal vector is projection of A onto B minus A, and give us the orthogonal vector. Now we saw that the projection was B, or A dot B divided by magnitude of B, this is the scalar component, times the B divided by direction of B, that is the direction of B. If you remember quickly, we saw A dot B is equal to magnitude of A times magnitude of B times the cosine of the angle. We want to know just A, magnitude of A times the cosine of B, because that is this projection. So it's just A dot B divided by magnitude of B is the scalar component. And next we want to know the vectorial projection, that is the scalar component divided by, the scalar component multiplied by the direction of B. We saw the direction of B is B divided by its magnitude. So we have this scalar component times the direction of B is the projection of A onto B. And the orthogonal component would be, I'm calculating this A, so let's say A is equal to A dot B divided by the magnitude times B divided by the magnitude plus the orthogonal vector is A minus A dot B divided by magnitude of B times B divided by magnitude of B. This is the orthogonal vector to B, and this is the parallel vector, that is the component of A in the direction of B, or the projection of A in the direction of B. Something that I forgot to say in the previous video was just the application in physics when we talk about work. Work is equal to force times distance. It's not quite just force times distance, actually it's force dot distance, because force is a vectorial, distance is also a vectorial, that is, the distance has a direction, force also has a direction. The issue when we talk just work is equal to force times distance, as usually, is because here we have the mass. Let's say that the mass is moving in this direction, and we want to know the work done, or actually the mass could be stationary, and we want to know the work done in this direction. Let's say in this direction, in the direction D, when we apply some force F. this force F, when we study just work equals to force times distance, like this, is because the force that we're applying is exactly in the direction in which, or the particle is moving, or in the direction in which we want to calculate the work done, but is that the force is parallel. That is, let's say A is in the same direction as B. So when we do F dot D, F dot D, we have the magnitude of F times the magnitude of D times the cosine of this angle, the angle between the direction in which we want to know the work, that would be the distance, and the force, that is, we are applying the force in this direction. So is cosine of 0 degrees, and we just have force times distance. But when we apply the force, let's say a force like this in this direction, and we want to know the work done in this direction, so we want to know, it could be the vectorial, we could know the vectorial projection, or we could know the scalar projection. If we want to know the work done in this direction, when we apply a force in this direction, we want to know the scalar component of the force onto the distance. That scalar component is the force, or first would be the force that we are doing in this direction, and then we multiply times the distance that it travels when we move the object. But so would be the magnitude of the force times the let's say times the magnitude of the distance that we're moving, times the cosine of the angle, that now the angle would be between this and this, would be this angle. So now would be cosine of theta, and now not would be only force times distance, would be less work done than it would have been if we just have put the force in the same direction as the distance.